Hi, my name is Vincent. I'm an algorithm guy from Amsterdam. And in this series of videos, my goal is to sort of explain what it's like to use spaCy. It's a fun tool, but it might be helpful to have a couple of videos to show you what it's like to learn and to use and stuff. Now to do that, what I kind of want to do is I could talk about the API and that sort of thing, but I think it's more useful if I go ahead and, pick a problem and see if I can hack it. So what I think might be a fun one to do is I like to find the use of programming languages in sentences. So for example, if I have a sentence, I like to program in Python, then I would like to say Python, that's a programming language, I want to detect that. Another example could be I like to use concurrency in Go, and then Go can be another programming language. You can kind of imagine this is kind of like a relevant problem. If you're, let's say, a recruitment agency being like if you can automatically grab the different programming languages, and that's useful. If you're Stack Overflow, detecting that is also super useful. So it's a cute problem. It's also kind of relevant. And what I'll do in this video is we're just gonna get started with spaCy. But to show you the power of it, I'll first grab a data set. Then I'm gonna use just basic Python to see how far we're gonna get. We're gonna sort of see what the problem is that spaCy wants to solve. Then I'll use spaCy, and we're gonna try a couple of approaches. And then we're going to benchmark these approaches and set the stage for the next video, because this video will be part of the series. So let's fetch some data. Let's start with that. The cool thing in this particular case is that I don't have to scrape any websites. This data is readily available. The kind people over at Stack Overflow have open sourced some of their data sets, and they're hosted on Kaggle, so it's pretty easy to download. Now there's a few data sets that you can have, and they're pretty fun to have a go at. But the data set that seems the most interesting to me is this Stack sample data set. I believe 3 years ago, it's about 10% of all the questions that they had. And you get 3 data sets. You get the tags that are associated with a question, you get the answer to a question, and you get the actual question itself. It is a pretty big download. If you press this download button, you're going to get a zip file. But this is the data set I'll be using in this video. So if you want to program along, you can just go to the Kaggle website and find it. So what I've done is I've downloaded the dataset, unzipped it, and it resulted in these files. I've got my answers file, my questions file, my tags file. And just as a getting started bit, I've loaded this library called Pandas. Pandas is a pretty useful tool to parse CSV files. I won't be using it that much in this video, but for merging and joining and that sort of thing, it's quite useful. But just to get started, what I've done here is I've said, hey, Pandas, let's just read the CSV. And for now, let's just only concern ourselves with the first 1 million rows. I'm only interested in 2 columns initially. I might use this ID column later to do some joining. And I'm for now only interested in the title of the question. And when you're loading this in, you do want to be careful. Please use this encoding. Without this encoding, you're going to get weird errors once in a while. So be sure to use that. And what I've done here is I've just turned that data frame that once it's been read in into this list, and we'll use a list from now on to sort of explore what we have and that sort of thing. So let's just use the random library to get some impressions of what we have here. So I kind of always like to at least peek around before I actually do something with it. But let's just get 20 random titles. So there's a few things in here. So I see that there are some tools around here. So I see WebKit, I see Android, I see jQuery. But I also see, for example, here JavaScript. And this is pretty cool, right? So JavaScript is fine, but that's the thing, eventually what I would like to detect. For now, though, I think it might be okay if I just constrain myself, just a little bit. Let's see if instead of going for all the programming languages out there, how about just constrain myself looking for one of them? And if I'm going to constrain myself to look for one programming language, I think a fun one might be to look for Go. There's a couple of reasons for it, and we'll see why in a moment. So I'll try to write some normal Python code now to see if I can detect if a question is about the Go language. So with that said, let's clean this up a bit. So we had our titles. And I guess a simple way of doing this is just to use basic string matching. So I'll write a function, has Golang. So just does it have something about Golang in it. In goes some sort of text. And what I'll just do is I'll type something like if go in text, return true. I can write that in one-liner. Just return this. And what I'll do now is just some sort of, so I'll do a small generator trick now actually. So what I will do is I will make a generator for all of these different documents. Yeah, so title for title in titles. If has Golang title. And the nice thing about this trick is I can call next on that generator for like the first two of them, and this way I don't have to go over all the titles because this will just give me 2 instances. And when I run this, I immediately see a bit of a problem. So Go, of course, is, that's the text I'm interested in, but Go, unfortunately, is in lots and lots of words, because the substring Go is in got, and the substring Go is also in good. So that's no good. One way to maybe circumvent this is to sort of recognize that you might be able to do something more. So you might be able to say like, oh, like I can maybe add like a space, right? That way, at least I know that there's going to be a space. So it might be a word that follows after. But even that is not great, because then you get stuff like Django. And Django is, of course, a very popular programming framework. Nothing wrong with Django. But Go now is also still a substring. Now I could go a step further and I can maybe put like another space in front of it. And then you kind of get this other natural problem, namely that the word go is very often a verb. So for example, where does console write line go in ASP.NET? This would also be invalid for the programming language Go. And I could go a step further. Like what I could do is I can maybe accommodate for like capitalization. What I can also do is write a very proper regex. That probably would be a fine thing to try, but this is one of those instances where you can clearly say basic string matching is just not going to help us. There is some inherent meaning of this as a token, and that's not being accounted for when I'm doing mere string matching. So I need to go like one step further. So what I'll do now is I'll just demonstrate what spaCy might be able to do. I'll just take a small detour to just explain spaCy a bit. And once we've done that, we can go back to our original problem. Now, let's first start by just importing spaCy. I've downloaded this beforehand. And what I can do is I can type NLP is spaCy.load, and then the idea here is that I'm going to give it a name of a model that I would like to preload. spaCy comes with pre-trained language models, and I'll just load one of them, and that'll be saved into this NLP variable. So the name of the model I'm going to go ahead and use is the EN Core Web SM model. That's short for English Core Web SM. So the SM stands for small, web stands for the corpus that it was sort of trained on. It might be that if you run, you get some sort of error. So with that in mind, it might make sense to make sure that you've run python-m spaCy download en core web sm. So just make sure you run this command before running this, otherwise you might get an error. But if you've downloaded this like this beforehand, then everything should be fine. And what I've done now is I've got this NLP object, and there's some stuff in here. Let's see that. So I'll give it a sentence. My name is Vincent. And when I run this, it almost looks as if it's a string that's being outputted, but it's not necessarily true, because what I can do is I can just check the type. And this allows me to confirm that the type of object that I'm seeing here is indeed a document. It's a spaCy document, so it's a special type of object. And a way to sort of confirm that this object is special is by realizing that you can loop over it. So if I were to just make this small little list comprehension here, you will notice that this NLP object is a collection. And one of the things that's special here is it seems that every word in the text has an associated sort of member in this set here. So let's zoom in on that a little bit. So what I'll do is I'll make a variable called doc. I'll put my name is Vincent in that. And what I can then do is I can just query the first element, which is mine. I'm just going to save that into a variable here. Now, just to confirm that this document contains tokens, and we can confirm that that's the case by checking the type. So we indeed see that these tokens here are indeed spaCy tokens. So this document is indeed a collection of sorts, but it is a collection of tokens. And the cool thing about these tokens is they have lots and lots of properties. So if I press .tab here and just have a bit of a look, then you're going to see that there are all of these properties that are being estimated on our behalf. So some of these properties are the result of a natural language model, but these are all properties that we don't have to generate ourselves. These are all properties that the language model can give us. So another way of experiencing what spaCy does is we've seen properties with a token, but another cool way of seeing that is to just look at some of its visualization tools. So spaCy is one of these. The way that this works is you can just type spaCy dot render, and what you then pass it is a document. So I can just grab this doc right here. So what you're looking at here is sort of the dependency graph grammatically of the document that we've given it. So you can, for example, see here that my name is Vincent is the sentence, and it's able to detect whether or not a verb is a noun or a verb. And you're even able to sort of recognize whether or not something is possessive. Now, you might come across lots of words or abbreviations that you may or may not be familiar with, especially if English is your second language. I can imagine that you might have to be reminded what atter and pos means. So just as a helper, know that spaCy comes with this explain command, where you can put something that you see here in there, and in this case you can see that pos indeed is a possessive modifier. And in this case, that also makes sense because my is possessive. Now, the properties that you can see here aren't just available in a visualization, they're also available from the spaCy library. So if I were to just make a very simple for loop, for t in doc, I'll print the token and I'll print some of these properties. So whether or not something is a noun and a verb that is known as part of speech, and whether or not sort of this dependency structure, you can access that by calling dep underscore. You can see that these properties right here are also available to us in this code here as well. And let's now consider why this might be useful. And to do that, I'll just grab an instance of a problem that went wrong. So I'll type NLP and I'll just put the title of the question in there where we saw a mistake. So with basic string matching, we might recognize go here as a programming language, although it's a verb. But what spaCy now offers us is it gives us a pretty good, it's an estimation, so there might be some errors here and there. But for free, I do seem to be getting a property here that says whether or not the word go here is being used as a verb. Now I can already imagine that if I want to detect go, the programming language, knowing that it's not a verb can already be something that is quite useful. So I can use some of these properties to write logic, and that is something that I'll explore now. Now, one thing I do just want to briefly mention about these properties that we have here. So those properties that I've just mentioned, if you go to the spaCy documentation, you go to usage and then to linguistic features, you'll get to this page that gives you a lot more detail and also demonstrates lots and lots and lots of properties that I will not discuss in this video. These documentations are great, it's pretty clear, and I can highly recommend you have a look at this if you're interested in knowing more. So know that the documentation is out there and it's great. Let's now go back and write code to detect the Go language. So back to the problem at hand. What I'll do now is I'll improve the code that we had before, make sure it makes use of spaCy. But one extra thing that I did is mainly a performance thing. I have added a little bit of pandas logic to make sure that I'm only looking for titles that actually have the string go in it. This is mainly a performance thing. Pandas is just a little bit faster than Python because of factorization and other reasons. But know that I've changed the code here a little bit, but I'll be focusing now on how to change this function to make this bit of code work for us again. So the first thing I have to do is, text goes in, and if I want to have spaCy do stuff, I first have to change it into a document. So I'll first say NLP text, and that will turn it into a document. Next up, I'm going to loop over all the tokens in that document. And then here I can perform some logic. Now the first thing that I'd like to do is there's one property called lower, which basically takes the token and makes the text lowercase. And I would argue I would like that to be either Go or Golang. Golang is also a common way of describing Go, the language, so I'll just go for both. Another thing that I'd be interested in, I would like to know for sure that the part of speech is not a verb. And I should not forget the if statement. When these things hold, I would be pretty comfortable with returning true, and I would like to get false in other situations. So I've changed this logic. Let's now see what comes out. So it's better. Definitely the verbs seem to be gone, and I actually get something I would argue is a hit here. So embedding instead of inheritance in Go. So this is definitely a hit. This is about a programming language, so I like to see this. But it's not quite perfect yet. And I see two main reasons. There's one example here where it says, hey, there's a Go button, and here Go is sort of describing something. And I can imagine here that Go is sort of describing this noun here. So one thought I have is maybe I should be more strict and have Go or Golang be the noun in the sentence. But another thing that I see happening here is I see this in one go happen. So, you know, like that's sort of a saying, in one go. So I'm kind of wondering what is happening here and why this is going wrong. And a common thing, at least something that I like to use then, is I would like to just take a couple of examples that work well. I like to take a couple of examples that don't work well, and I'll just chug them into the display tool. Maybe I can see some sort of pattern by doing that. So let's get an example that works well. So spaCy, render, NLP, this guy. Okay. So Go is indeed correctly detected as not a verb, and it seems that the relationship with the previous word, let's just peek here, just spaCy.explain. Yeah, so the dependency structure of this token is that it should be an object of preposition. I'll check this with an example where it's not going well, just to confirm if, you know, like, I'm not the biggest grammar expert, but I can imagine that that might be a beneficial thing. Okay, so there's Go. It's a noun, and okay, so it seems to have an auxiliary relationship there. So, okay, so maybe if I can change this logic that I have a little bit such that it also takes the dependency into account, I might be able to get some more accurate things coming out of this. So let's build that. Now building that should be pretty easy, because the only thing I gotta do is I gotta make sure that I also keep, just gotta make sure that there's an object of preposition as a dependency structure, and then and only then am I gonna return true. So let's see what pops out of this. Okay, this seems to be working. Yeah, okay, so now the first 5 examples that I get, they're all correct. So this is a good position to be in. Now, just like a mental habit. It is very tempting right now to just immediately just go through with this. But personally, I always find that if I have this moment where I'm definitely sort of onto something, that is a great point in time to start formalizing. So this code works right now, but what I probably want to do now is fiddle around a bit, and I'm interested in maybe doing some benchmarks, trying to figure out what works well and seeing if I can quantify that. So what might be good now is to just change this code up a little bit such that we can make it a bit more performant and that we have some nice language patterns that we're using here. So the first thing that I kind of want to do here is I want to make use of a pattern that we have in spaCy called NLP.pipe. So here's the idea. The idea of NLP.pipe is if you just pass a huge list to this pipe method, then essentially the documents that are in here can be handled a little bit more performantly because the internals of spaCy can help you out there. Now, let's just do a benchmark to show that this indeed does help. So what I'll do is I'll just add time here. This is not the best benchmark, right? But let's just run this for the first, I don't know, let's get the first 10. So I'll run the timing on this without NLP.pipe, and then we can compare. So I get some results out of this, but this seems to take about 25 seconds. So let's now use NLP.pipe, and we got to remember it's 25 seconds. So I'll just put NLP.pipe here. The idea behind NLP.pipe is this should have we should get more performance out because the internals of spaCy are able to do stuff on our behalf. The one thing we got to remind ourselves of though is that this function will now no longer receive a title, but it will receive a document. So let's be consistent with that. We gotta take this out and make sure that we pass it a proper document. So let's, again, we just had about 25 seconds. Let's now run this. So this was done in about 5.5 seconds. So that's definitely a substantial improvement. There's one extra thing that we could do. And that extra thing that we can do sort of has to do with this model that we've got here. Because it's a bit under the hood, but what this model here is doing is it's not just deciding whether or not something is a verb. It is also doing tokenization, and it's also doing lemmatization, and all sorts of stuff that we might be interested in. Now, this is great if you actually use all of that stuff, but at the moment there are parts that we're not using. And in particular, the part that we're not using is the NER module. That's for named entity recognition. And we'll get to that in a later video. But for now, I just want to show that if you turn that off, so I can say this is a part of the pipeline I want to turn off, that stuff runs a whole lot faster as well. So let's just run this and see what the difference is. Okay, so now it's about less than 4 seconds. So I'll gladly take that. That's like definitely another improvement in terms of speed. So as a next step, what I'll be doing now is I'll write a little bit of code that allows me to do some logging and allows me to play with this a little bit. I don't think I'll ever change, this predicate, but I'm definitely interested in sort of calculating maybe the precision and the recall if I fiddle around with this and if I fiddle around with that. I just want to get a kind of like an idea of if this were a proper proof of concept, can I maybe quantify my results such that I might be able to argue keeping on with this idea, or maybe switching gears a bit and trying out something else. I think I'm onto something, but let's now use this faster code to maybe do some benchmarks. And the way that I think we should do these benchmarks is it's not going to be perfect, but we do want to have some numbers that mean something. So what I would like to do is I would like to say, look, from the datasets that I downloaded originally, I had this tag that I can use from like tag CSV that I can join with questions.csv. And the idea there is that the tag is able to confirm to me that there is a question about Go. Now the thing is that, of course, if a question can be about Go without the programming language being mentioned in the sentence. But imagine now that I take all the questions that are about Go and I look for all the instances where I have Go in the text. This overlap between these two, that I should be able to quite accurately pick out from the entire set. If I'm able to do that, then I have a pretty good rule. Now, what I don't want is things like in one go coming out. So if I just query for does the substring Go appear in the text, then I get lots and lots of candidates that I'm not interested in. But if the tags CSV file confirms that those titles that has Go in the text is actually about Go, okay, then I'm willing to say as a proxy that is something I can use to do some benchmarks. So I will go and write this now. See you in a bit. All right. So again, there's some patterns code in here, and I apologize if you're a bit unfamiliar, but I'll just go through the logic that I've done. It's not perfect, but it's a pretty good proxy. So the idea is that what I've got here is these are the tags. So this is a data frame where it says, okay, here's a question ID, here's an associated tag. And what I'm able to do is say, okay, look, here's just some IDs that would be a match, and these are the IDs that match the Go language. Now what I can do is I could go ahead and fetch all the Go sentences. So these would be all the titles that actually are about Go. But you have to imagine that some of these things are, tools more than the language itself. So anything that is, what I would argue, detectable is going through this NLP pipeline where at least I can confirm that there's a Go or Golang token in there. If Stack Overflow says it has the Go tag and I can detect Go or Golang in it, it's not going to be perfect, but I do believe that there's something I should be able to detect. Now there's also a set that's non-detectable. So I'm doing a sort of a performance trick in here, but the main thing that's important is that we recognize that these are all strings that do contain Go as a token, but are not part of the tag. So these would be questions that might have the token, but they should not be of the class that is actually about the Go language. So when I run this entire thing, I get some nice numbers that sort of help me understand what sort of quantities we're talking about. So the numbers that there's some numbers I get out. It seems that I should be able to detect about 1,200, which is a nice number. If this was like in the hundreds, then this number might not have been so convincing. But it seems like I got about 1,200 titles where Go has been confirmed by both the tag and it's also a token. There's also a few things where Go is in there, but it's not part of the Go tag. There's also some questions argue about 600 that are associated with the Go language, but don't contain the programming language in the question title. So this is good enough. Like I have a set here, which is the ones that I'm interested in, and I've got my set there, which is sort of the thing I'm afraid of. So with these sets defined, the code, which just whipped up real quick, that will sort of be logged, looks like this. So I have this function called hasGoToken. This function will make use of a document, which will be supplied by this model, and I've got some sort of method name here. And sort of the idea is in this part of the code block, I'm defining a bunch of stuff, and below here I'm calculating a bunch of stuff, which the final line here is the thing that's getting logged. And the stuff that I'm calculating is I'm taking the model that I've defined up here. I have a set of things that I deem to be detectable. I count how often those are true, and that those are the numbers that I have correct. I have the same thing where I can say, hey, you're doing that wrong. And then I can sort of calculate the precision, the recall, and the accuracy. And I'm aware of the fact that these, of course, are kind of heuristic based, but these sort of ballpark numbers should help me in understanding whether or not I'm onto something. And that's sort of the goal in this phase. And of course, like with all of this stuff set up, I can maybe use a different spaCy model. I can take the medium-sized one, I can take the large-sized one, and I might be able to say like, oh, it doesn't have to be not a verb, it has to be like exactly equal to a noun. And every time I do this, I can sort of change the method that I'm using, and the model name gets logged. So the goal is to just run a big benchmark now and just see what results come out. So you gotta imagine this took a while, but now I have this very cool little table with results. What I have done is just for fun and kicks, I thought it might be fun to do. It's also kind of, to be honest, it's actually kind of a useful thing to do. Like try to run a benchmark to confirm that if you do something stupid comes out. So usually you want Go not to be a verb. So I figured, how about I run one instance where Go actually is a verb? Those are the three you see here. Now I'm going over different models, but one thing that you can clearly see is, precision, recall, and accuracy, they're all quite abysmal. They're really, really low. So then, there are some other approaches. One thing I said is, how about I say that I do want this P-object relationship, this dependency, I do want that to be in there, but I don't want you to be a verb. Get really, really high precision. So if I say that you are a Go language, I'm really, really certain of it. But I only get about 35% of all the possible ones. So, the precision is really good, but the recall is kind of abysmal. Then what I do is I try to take what happens if I maybe say, well, I don't care too much about the dependency, what happens then? Then you kind of see that, the precision does take a bit of a hit, but at least for the small model, the recall seems to be a bit better. And if I were to compare saying like, hey, maybe I want to be more precise, I want to say, hey, it has to be a noun. I get it's not the worst, but I essentially kind of get this now. So you can compare lots of numbers. In general, the one that seems to stand out for me, at least right now, and I should stress this is a manual thing we kind of wrote, But I think I kind of like this one. So it's about 90% accuracy. We get about like 70% recall or so. So this, we have an approach where I would argue here, like it does depend on the use case a little bit. But this is looking promising. Like this is something that we, as far as the proof of concept goes, I would argue here that spaCy is indeed doing something useful. It's something that I programmed maybe in a few hours. I can already see some places where if I can iterate on this just a bit further, I might be able to get something maybe in a production setting where this would do something useful. So what have we done? We started by wondering about a problem, and then we got ourselves a data set to see if it was solvable. We very quickly came to the conclusion that language itself is more than just a string of text, and with that in mind, I was able to show some good use cases for spaCy, and we were able to demonstrate some basic usage. We got some results and we benchmarked them. And that's sort of the point where I am now. Now, it should be mentioned, though, that I'm, of course, not done, because this is just the beginning. What I want to do is I want to use my current approach to aid in labeling for general programming of languages and tools. I would genuinely be interested in being able to parse, say I've got a resume, I'd like to be able to parse tools that people are using. Once I have these labels that I can sort of, I still have to do some labeling there, but once I have them, then I might train a model to recognize a programming language as an entity. And once I'm here, I would like to benchmark this against some data that isn't from Stack Overflow to further stress test my application. I should, of course, remember that, for example, Python, that could also be a snake, and Java, that can also be an island or a type of coffee. So you will see another video where I will take the approach I currently have and I will expand on it. So just some takeaways, at least from my side. Do recognize that language is more than just a string of text. Also, even though spaCy is not 100% accurate, it still allows me to easily build some rule-based systems that I would not be able to write with simple text matching. It really feels nice to be able to build a regex not on top of text, but on top of meanings of tokens, and that's quite liberating. Whenever you're doing something, it is always good to remind yourself that you're trying to solve a problem first and foremost, and therefore it also makes sense to maybe get a pipeline working and to take your time to clean up your code once you've hit a milestone. With having said all this, definitely give spaCy a try, and I'll see you next time.